Okay, in this lecture we're going to talk about hyperbolas. For analytical geometry we've gone over parabolas, which can look like this, up or down, or left or right. Ellipses, once again we can have left or right or up or down ellipses. And now hyperbolas. They look a little bit like almost back-to-back parabolas, not quite the exact shape. There's always two parts to the hyperbola. We call this an up and down hyperbola. We can also have left and right hyperbolas. So this is what we're going to talk about today. What's interesting, if you recall about ellipses, the equation for an ellipse, there are two possible equations. Let me just write one of them. X minus a squared over a squared plus y minus k squared over b squared equals 1. What's interesting, you take the equation for an ellipse and you make one change and you have the equation for hyperbola. And that change is simply, instead of adding these together, we subtract them. So let me just give you right off the bat the two standard equations for hyperbola, and then we'll dive into what it all means. So you can have an up or down hyperbola, and that's going to look like this. Well, let's do left and right first. Sorry. A left and right parabola will look like this. Looks almost the same as the equation of an ellipse, except we have a minus. Then up, down. You know, so one thing I'm going to do is here, it's like, I'll call this the x term. You notice it's sort of positive, and you subtract the y term. For an up or down, you simply switch the x and the y. So now the y term becomes sort of the positive term. And you subtract the x term. Notice what's key. A squared is always positive. So in this case, since the x is like the first term, the a squared's here. Over here, the y is the first term, but the a squared is still here. When we did the ellipse, the a squared was always the largest number. If you compared a squared and b squared, a squared is always a larger one. That's not the case. Matter of fact, sometimes a squared can end up being a smaller number than b squared. The size of the number does not matter with an hyperbola. What's key is the a squared is always part of the positive term. Let me go ahead and make a sketch of a hyperbola to define. I guess the key things are, we've got h and k and a and b. So for example, let's assume we have like we'll just do a sketch of a left-right parabola. So let me write the equation for left-to-right parabola. X minus h squared over a squared minus y minus k squared over b squared equals 1. HK is a point, and it's going to be the center of the parabola. So let me sketch a parabola, and for this example, we'll put the center of the parabola at the origin of the x and y axis to make it simple. So there's the center. Now, since I know this is a left or right parabola, I'm going to move a distance a, both in the positive and negative direction. And I'm going to move, in this case, up and down a distance b. So what you do is, when you normally try and graph a hyperbola, you graph your center. Once you figure out your a, you move, in this case, left to right distance a. You figure out your b. You move up and down distance of b. And then what's interesting is you're going to draw a box, or usually a rectangle, and it goes through these 4 points. And what you do next is, now I'm going to draw through the corners of this box and through the center another dashed line, except these are like diagonal. And when you do that, I can now draw my hyperbola. These vertical lines are like asymptotes, which means my graph gets very close to these lines, but never touches it. And it goes through these points here. And this side, the same thing. So there's how we're going to graph our hyperbola. Center, this point, is called, some books call these vertices. Yeah, they're called vertices. Now there's also 2 more points called the focus and the focus. They're always sort of inside And there's actually an equation we call the distance from the center to the focus, we call that C. Then you have a little equation you can always find the focus if you know your A and your B. Or say they give you a focus point and another point, that you can find either one of these. All right, let's do some examples and you'll see how this is done. I don't think you'll find it too complicated. Of course, we'll start out with some of the easier examples, and then they'll get a little more complicated. So let's say you're given, okay, and let me point out one thing. With these equations, just like an ellipse, the standard equation, you notice there can be no number or coefficient in front of either this x term or the y term. And also notice it has to be 1 over here. The only numbers you can have are in the denominators. No numbers in front of the parentheses. This has to be a number 1, and then you can have numbers down here. Sometimes they may give you an equation where you have to do a little algebra to get it in the proper form. Now the first example we're going to do, we don't have to do that because once we take a look at it, we realize the equation is already written in standard form. So we want to graph this hyperbola, and we'll go ahead and we'll determine the vertices and the foci and even some more stuff as we go along. So first thing you notice is, first thing you have to ask yourself, is this a left or right or up and down? And the whole key is, what is positive? If x is positive, it's going to be a left or right. Now in this case, if we compare our equation with the standard equation, I want to first determine the center. Hopefully you can see here how x squared I hope this is obvious to most of you, but in case this ever confuses you, so the center for this one is 0, 0. So the center is at the origin. Now we need to determine A and B. A squared is always the positive term. So A squared is 16, which means A is 4. B squared is 4, which means B is 2. And now, see if I have room to graph this over here. So here's the center. Now let's step off the A. Now since this is a left and right, A is in the horizontal distance. So here's one of my vertices. Ends up being 4, 0. So I go a distance of 4, which is A, and I also go a distance of 4 the negative x direction. So that's another vertex. Now, let's use my B to figure out the up and down. So since it's 2, I move up 2 from my center and 2 down from my center. And now I have these 4 points, and I'm going to sort of, in this case, draw a rectangular box that goes through those 4 points. And now I go ahead and draw my asymptotes, my diagonal lines that go through the center and the corners of the rectangle. And now I can go ahead and draw in my hyperbola. Sometimes you get confused and maybe you start to draw that hyperbola here, but you got to remember this is a left and right hyperbola. So it looks something like this. So if I want to just do some labeling, the center is 0, 0. I can say the vertices were 4, 0, and negative 4, 0. If I ask to find the foci, once again, c squared equals a squared plus b squared. So that's 16 plus 4, which is 20. So I take square root of 20, 2 square root of 5. I didn't bring my calculator, so the foci is probably out here somewhere. But if I want to give the actual point, it's 2 square root of 5, 0. Negative 2 square root of 5, 0. Now the last thing they like you to do sometimes is, sometimes they want the equation of this asymptote. Of course, these are straight lines, so we have slope-intercept equation. Of course, the y-intercept is 0, which is nice, so b is 0. So we just have to find the slope, and you know what? If I go from here to here, the slope is rise over run. Rise is how far up you go. What is this distance here? That's b. From here to here is a. So the slope is b over a. So that's one asymptote. The other asymptote is almost the same, except just the slope is negative. All right, so we've completed this hyperbola. Let's just do a few more. What if you're given this equation? You're told it's hyperbola, and you're asked to graph it and give all the important information. First thing you have to do is get it in the standard form, which means you get the x squared and the y squared on the same side and the number on the other side. So obviously I need to move the 4x squared to the other side. So if I subtract 4x squared from both sides, now this is not in standard form yet. One of the main problems is this has to be 1, and I also can't have this 4 here. So let's just divide both sides by 4 to make this 1, and we'll see what happens. Now if I look, looks like it is in standard form. So now I decide, is this a left or right or an up or down hyperbola? Since the y term is a positive term, it's going to be an up or down hyperbola. Now this is just like the last one now. Should go fairly quickly. We know the center, it's once again 0, 0. A squared is 4, which means A is 2. B squared is 1. You can think of a 1 being here, which means B is 1. C squared is A squared plus B squared, which is 5. So C is square root of 5. And now the center is at the origin. Now, since it's up and down, A, I move up 2, down 2. Since B is 1, 1 to the right, 1 to the left. Make my rectangle. Draw my asymptotes. Now remember, this is up or down, so I'm going to go like this. So it should be more round than I've drawn them sometimes. And there we go. Vertices in this case, 0, 2, 0, negative 2. The foci are down here somewhere. Zero, square root of 5. 0, negative square root of 5. And then I could do the asymptotes, but I won't do it for now. All right. Let's just do a few more. X minus 2 squared over 4 minus y plus 3 squared over 9 equals 1. So this is an hyperbola, which we want to graph. First of all, let's determine which kind of hyperbola it is. The x is the positive term. So it's going to be the x minus h squared over a squared minus y minus k squared over b squared equals 1. So this is going to be a left or right hyperbola, since the x is the positive term. Looks like a is going to be 2, b is going to be 3, c squared is going to be 13, so c is square root of 13. And with that, let's do the center. X minus 2. Remember, the way I think of the center is think of the opposite. So this is a minus 2 here. So it's going to be 2, and this is plus 3. So it's negative 3. So the center, 2, negative 3. There's the center. Now A, I'm going to go left. It's a left and right parabola. So A, I'm going to go left 2 and right 2. So the center is this. So if I go, here's a vertex. Let me write this down while I'm doing it. So if the center is 2 minus 3, this looks like 4 minus 3. And then if I move 2 over here, that's another vertex. 0 minus 3. Now up and down, my B is 3. So it looks like right here and right here. Now I can draw my box. Draw my asymptotes. Now don't get confused here. Once again, this is a left and right. So I'm going to go over here. Now the foci probably be here and here. May not be perfectly drawn. The foci, you go from your center and you add square root of 13. So it's going to be 2 plus square root of 13, negative 3. And then you subtract square root of 13 to get your other one. And maybe for this one, let's go ahead, see if we can figure out the equation of this asymptote. It's a little more complicated because it's the center's here. Let's use the point slope equation. Let's do the positive one first. Point slope says y minus y1 equals the slope times x minus x1. For my point, x1, y1, I'm going to use the center. So y1 is going to be negative 3, so it's going to be y plus 3. The slope is still going to be b over a because I go up b and over a. Three halves, and now my x1 is the x of my center, which is 2. So if I get y by itself, 3 halves x minus 3 minus 3. It looks to me like, if I mess up, this is the equation of this line. Negative 6 is my y-intercept. Looks about right. Then I could do the same thing to find the other equation. All right, so not too bad. Now, let's look at a couple variations. How about you may see problems like this where they give you information and they want you to come up with the equation. For instance, I say here's an hyperbola. They say the vertices are -4, 0, and 8, 0. And then they say the foci is -8, 0, 12, 0. And they want you to give the equation of that hyperbola. The only way to really solve this without making a mistake, you have to go ahead and just graph it. You may not have to graph the whole thing, but really to know what's going on, you really have to graph it. So the vertices, -4, 0, that's a vertice, and 8, 0. So we know the center is going to be halfway in between the vertices. So if this is -4, 0, this is 8, 0, the distance here is 12, so it must be halfway, must be 6. So that must be the center. Which gives me my h and k. Now I know from this graph right now, this is going to be a left and right parabola. So let's write the standard equation for a left and right parabola. So the x comes first. X minus h over a squared minus y minus k squared over b squared equals 1. Since I know the center, I know h is 2 and k is 0. And actually, let's figure out the a. The a is this distance here, which is 6. So really, the only thing I need to figure out is what is b. Once I know b, then I have the equation. B is like this distance here, which I can't really figure it out. But what else do they tell me? They tell me the foci is -8, 0, and 12, 0. Which means the distance C is the distance from the center to the foci. So if I look here, if I'm at 2, 0, and this foci is at 12, 0, what's the distance here? 10. So it looks like C is 10. And I know C squared equals A squared plus B squared. So C squared's 100, A squared's 36. So B squared, 100 minus 36 is 64. So B must be 8, or I guess the key is B squared 64. That's what I really need. So my final equation for this hyperbola there you go.